Hello, my Flat Earth family. This is, Marilyn Spirit Level. And came across this video and I thought this was really good. But he is a globalist. So I'm going to put a little bit of different spin on it and see what's going on. But the information is really good as it pertains to the principles of density and buoyancy, which many in our Flat Earth community are kind of like stuck on. So this really shows it very clearly. So I'm going to play some of this, and then I'm going to fill in where need be.
So I just wanted to talk a little bit about gravity, because I understand it's quite difficult for people to get their heads around gravity when looking for proof of it, other than just dropping something. So when flat earthers say, well, the explanation is density and buoyancy, that is something that we can actually test to see, is it density and buoyancy, or is there actually something else? Is there an actual force that we call gravity at work? And so that it's not just down to density and buoyancy. So I'm going to show a couple of videos here, but I just stumbled on this one I've never seen before. Basically what they did, they've got water in this tube, then they've got water and oil in this green tube. And you can see that because of density, in the green tube, the two liquids, the water and
there's
oil,
some buffering.
They are separated.
I don't think it's mine, I think it's his.
Okay, because they have different densities. But they only do that because there is a force, which we call gravity, that pulls down the more dense liquid.
And if you look at his video, which is there at the top, it says Flat Earth - gravity, not density and buoyancy, then you can try to find the original videos. He does show them later in here. But you know that we do not ascribe to gravity. However, this density and buoyancy idea is very, very interesting. So it's only 6 minutes more.
I know, which allows them to separate.
No, 9 minutes.
So in this video,
8 minutes
they're actually
more.
going to send these liquids up in a rocket so they can reach basically 0 G, and then we can see what happens to the liquids.
Now they send the rocket up, but then they have a camera on it, so you get to see.
Just them firing the rocket up.
You do get to see what happens to the liquid. So
now they're just going to go through the results.
See on the right there, the camera is fixed on the vials. There it goes up, and then
so
it reaches.
When there was thrust, the water stayed at the bottom. As soon as thrust stopped, and essentially he said that they've reached 0 G, the water moved to the top, and then in the green tube, the water and the oil just starts to mix, and it's no longer separated, oil at the top and water at the bottom. And then he talks about how the bubbles stop moving as well. You see the bubbles here? He said they're water bubbles in the oil, but they're not going up or down, and the water's staying at the top of the tube, not the bottom of the tube.
See, the blue tube only has water in it and air. The green tube has green colored water and oil filling the rest of it,
So this is the oil
with a little bit of air,
separated.
which does make bubbles. There's a big bubble.
Reach the parabola and effectively 0G,
The apex at the
water
top.
and oil become separated. Less separated.
Apogee. Yeah, there we go.
There's another video, which is the one I was going to show. This one.
See, now if you just go back to where he has his
tower.
You can see that, what videos he was looking at. We've all seen this.
A 0G plane.
The tube with the different
So you have liquids of
densities of fluids.
And then you can watch the effects of zero gravity.
This is really awesome.
So then the question becomes, if it's density and buoyancy that makes things fall down, why is it that density and buoyancy works, but then as soon as you control the environment and effectively remove the downward force of gravity, which we know, which is what the 0G plane does, and we'll see what happens.
This is really amazing to watch. So they're going up in the 0G plane, and at some point, look, instant.
So as soon as they hit 0G, the liquids, all the liquids in the bottle mix, become one liquid.
All the layers do not
no longer
separate
separated.
anymore. They're fluid, and they just
no longer know which way is down.
They just blend together because they don't know which way is down. There is no force.
So again, this just proves that there is a external force called gravity that causes density and buoyancy. Density and buoyancy doesn't work on its own.
So there is an external force. It's not just density and buoyancy that work on their own. There has to be a force. And this is what I've been saying when I'm teaching, that density and buoyancy are only properties within the force. If the force is gone, then those properties do not exist. See, it's only within a force that these more dense can separate and the less dense can separate. So we've got to say something other than density and buoyancy. Well, let's continue.
That's that video. What does the density tower do in 0G? That's worth going and watching. The first one was this one, liquids in near 0G.
There you go.
Then there's this video by Action Lab. Which way do bubbles float in space? Basically what he does is he's blowing air bubbles into a bottle of water, and the air bubbles are rising.
Okay, now with this video, the first time I watched it, I was focusing on the bubbles. But don't do that. You'll see that the bubbles stop. But don't focus on the bubbles and think, well, what is making the bubbles do that? Focus instead on the water, the medium that the bubbles are in. And then you will understand it. It will click with you.
Because the buoyancy. But as soon as he drops the bottle, you'll see what happens.
Did you see that?
As soon as he drops the bottle, the bubbles that are moving upwards because of buoyancy, they start to stand still. They don't move. This is just another example that buoyancy, density and buoyancy do not act alone. There is a force called gravity, because essentially what he's doing by dropping this bottle is removing that force of gravity once it reaches 9.8 meters per second squared.
Did you hear that? What this guy, even though he's a globalist, what he's saying is correct. So what you're doing is not, there's no effect on the bubble. Well, there's an affect, but there's no, the property that we're removing is the pressure on the liquid to force its way underneath the lighter air bubble. And that is what happens when you have a more dense liquid. It forces its way underneath the less dense. And that's how it displaces it. So it's not that the air bubbles are necessarily going up, but it's that the water is not going down. Do you understand how that kind of, it's like saying the same thing. You're seeing the same results, but it's actually more precise as to what is actually happening with that. So, and that was when I first watched this, I'm there, what is stopping that air bubble? But it's not that, it's the, what's stopping the water from displacing that air bubble. Let me finish this and then we'll talk.
Red. Just like the zero-G plane, just like the fluid's been fired up in a rocket. So all these little experiments show that density and buoyancy do not work alone without the force of gravity. And that's this video, Action Lab, which...
Density and buoyancy do not work alone. That's exactly what I've been saying. They're only properties within the force. So there has to be, when we talk to people out in activism, we have to provide an alternative because they can't wrap their minds around it. So that's why I take the time and explain the torus field. And I also say that within that torus field, there's diamagnetism. Now, there is diamagnetism, but I have not proven that on a large scale. So I am saying that this is my opinion, and this is what I am offering as an alternative. Now, I think it's a pretty darn good alternative. I think there's evidence for it, and I think it could easily be proven. But you know what? I'm going to let that for the guys who like to do that type of thing, where that's not my thing. I would love to see, I would work with somebody to do it, but for just me going out and doing that, that's just not me. So, all right, let's finish this up in just a minute.
Space. But once I saw videos like this, that just convinced me that there is proof of this force that we call gravity, and that density and buoyancy doesn't explain it on their own. Density and buoyancy does not exist without gravity, because it's gravity that's pulling all everything downwards. And so when you've got liquids, the denser, heavier objects, liquids, move to the bottom, the light ones move to the top. That's only because of gravity. As soon as you remove gravity out of the equation, which we know is 9.8 meters per second squared, as soon as you remove that, density and buoyancy stops working. It's like it doesn't know which way is down. So that's just visual proof there. So if any flat earther brings up the density and buoyancy argument, you just show them videos like this and then see what they say.
Okay, so that's it. That's the end of the video. And yes, he's right. The force defines down. And I can't tell you how many times I've written that. And I'm not criticizing any of my other fellow flat earth activists. It's that the force that is at work here defines down. Now, I don't think we're being pulled down. I think we're being pushed down. And that's perfectly fine. It's still a directional force. And so I just had to share this with you. Sorry if I was a little bit wiggly here on the video, but I'm just holding this and I have to get one of those little desktop things that look like an octopus to hold my camera so I can do these. I haven't really done too many of these, but this is interesting, so I thought I'd share it with you. And so have a great day, and get your calendars out and fill it up with flat earth activism that you're going to be doing this year. We've got to really put it on. We've got to do it everywhere. I went to another mall today to try and see if they would allow a free speech zone. It's in Pennsylvania. So I'm not having a lot of success, but I'm hoping that they will see the wisdom in this. But, okay. Love you, Flat Earth family. Bye for now.